Okay, so since we've changed what we were doing for homework tonight, I've gone ahead and shared one of our normal I do, we do type of worksheets with you guys. So I'm going to go through the I do and the we do so that you have that to help you as you work through this. As always, if you have any questions, let me know. I will also try to record myself working through each of the other problems as well. Okay, so we're going to start out with the I do. So we have this curve, and we can see that this is a strong acid, strong base because it's very nearly flat through here, and very nearly flat here, and very, very vertical as we go through the change. So we have hydrochloric acid and sodium hydroxide. This is a strong acid and a strong base. And we have sodium chloride formed as a product and water formed as a product. And if we look at our graph, we can see that if we were to try and put a dot in the center of this change and draw our line down, that we would find that the equivalence point is at 25 milliliters. So since we have 0.121 molar sodium hydroxide, and I'm titrating 20 milliliters of hydrochloric acid, this might actually be the same problem I did for practice last night. If so, I apologize. We have our 25 milliliters of sodium hydroxide. This is the molarity of the sodium hydroxide, so volume times molarity, moles per liter. And then we have moles of hydrochloric acid, 1 mole of hydrochloric acid for 1 mole of sodium hydroxide, and that gives us 3.025 millimoles of hydrochloric acid. We divide the millimoles of hydrochloric acid by the volume of the hydrochloric acid, and we get that we have 0.15, this should probably be a 0 here, molar hydrochloric acid. Oh, that's going to be a 1. Yep. Sorry, had my significant figures wrong there. Unless we assume that the 25 is too imprecise, in which case we would only have 2 sig figs. So it depends on whether we decide that that's 25.0 or 20. Either way, molarity of the base times the volume of the base, and then we convert to moles of acid, divide moles of acid by volume of acid to find molarity of acid. So for the we do, which obviously today will just be an I do, we're looking at this graph, much like the graph that you guys made in the lab. And this shows the titration of oxalic acid with sodium hydroxide. So this is a weak acid being titrated with a strong base. So we're going to label the equivalence point, we're going to estimate the pH at the equivalence point, and we're going to estimate the pKa of oxalic acid. So I'm looking at this very vertical section here, and I'm going to say that I think that the equivalence point is right about here. And so draw a line down from there, straight down, and we're going to get that that's pretty much at 30, maybe it's at 29.5. And our pH at that equivalence point, so again, drawing a line over to the side, is going to be just about 8. So this is our equivalence point. The pH at the equivalence point is 7.9, and we're going to estimate the pKa of oxalic acid. So pKa is equal to pH at the half equivalence point. So if the equivalence point is at 30 milliliters, the half equivalence point, this is the half equivalence point, is at 15 milliliters. So we're going to draw our line straight up from the half equivalence point, and that would be our half equivalence point there. And we're going to draw our line straight over. And I would say that that would be our pH there is equal to 2.5, so our pKa is equal to 2.5. So that's all we have to do in order to label those parts of the graph. Alright, and you guys have a few more problems to work through. As I said, I will record a separate video that works through each of these. As always, if you have any questions, let me know.